So here we have the BlueYeti EB200p. This has been my chosen head unit. It's got the upgraded inverter, so it can handle 2.2 kilowatts, and it has a slightly larger lithium-ion battery at 2048 watt hours. So I'm using the EB200p to power my home office. Home office load is not so large. It's roughly around 245 watts. That can go up to as high as 400 when everything's on. I'm also running the router and some equipment out in the lounge room, and I'll take you through how I've been able to do that. So I'm running, just got a couple of standard power boards here. Run ones under the computer desk here to power the home office and all of the screens for work, and the other one runs over to this power wall over here and powers the chargers and lights and other power boards that I've got on my workspace. So that's relatively straightforward. Now I can augment this, how am I charging this? Now I am predominantly running it off solar, but I do also have the AC connected. Sometimes I'll need to use the AC at night, particularly if it's been a cloudy day. Alright, so as I said, I'm charging off solar, and I've actually got 4 rooftop solar panels that I purchased secondhand, and I'll take you downstairs and have a bit of a look at those very shortly. One of the additional things though that I have made is I've used a battery monitor with a 200 amp shunt to provide me with some readouts that I don't need to wake up the touchscreen on the BlueYeti for. So this was just available from JCar. You can get them cheaper online. So the main reason I'm using this obviously is to give me an instantaneous wattage reading, so I can see how much power I'm generating, I can see the volts. But one of the big advantages, particularly because this is an EB200p and it doesn't have the Wi-Fi app, I don't really get a lot of parameters or readouts from the BlueYeti system. It gives you an instantaneous power generation and voltage. That's all it provides. So with this, which is just an inline meter, I can actually see the current that's being provided, I can see the watts, but now I can also track kilowatt hour production. So if I want to, I can actually have this running over a period of time. Now I installed this yesterday, so you can see it's been running for 14 hours and 38 minutes, and in that time, obviously a lot of that time was night, but it has so far, yesterday and this morning, generated 3.13 kilowatt hours. Now you can currently see that it's reading 0 watts, and that is essentially just because the BlueYeti is fully charged and is not drawing any power at the moment. We go into battery here, we can see that we are in discharge because it's switched off the incoming power from the solar. Alright, so what we'll do is we'll head downstairs and I will show you what I've got happening down there with the solar panels. Okay, so this is one of the banks of solar panels that I've got. I've actually got 4 of these, and they're 250 watt rooftop solar panels, so roughly around the 37 volt DC range. So I've got 2 here and another 2 out there on the fence, both having a very similar sort of aspect, and we're both looking towards the north here. It's working really well in the winter time, but as the sun's now starting to get up a little bit more, I've had to sort of put these on a bit more of a steeper angle. These ones are probably still a little too steep. They're about 60 degrees thereabouts, so we'll reduce a little bit of the efficiency from those panels. I've been able to lay the front ones out a little bit lower, and they're at about a 40 degree angle. We're here pretty much bang on the Tropic of Capricorn, so it would have been ideal to get them down around 30, but a couple 10 degrees or so is not going to make such a huge difference. So the way I have them set up is I run the 2 banks in either parallel or I can actually flick them over and run them entirely in series. So this is the control system that I've got here. I've basically just brought all the cables together, the two panels. So this is an overarching isolator which goes upstairs to the BlueYeti, and so I can actually shut off all four panels at that point. But I've actually wired up down here with an additional switch. Now this is just a standard light switch, but it is a double pole, double throw. So I guess in that example, it's probably not all that standard. So it's actually got 6 terminals on the back. And so when it's in parallel mode, basically it's pass through. So positive in is positive out, negative out. Standard parallel arrangement. But when I flick it over into series mode, the output connectors become disconnected, and there's a short internally in there which links these two positive and negatives together, which basically turns the 4 panels into a single array with them all wired in series. And I've just used the standard MC4 connectors over here and a couple of Y cables to facilitate the parallel operation. Okay, so that was the solar panels downstairs. Now just a couple of other features that I've got happening here at the moment. Now obviously the EB200p does support lead acid charging natively on the PV connector. You have to go into the setting and actually change the voltage and tell it that it's on car. So one of the things I did purchase the other day was the enhanced DC charger. That actually allows me to connect up to the AC input, which is actually a DC input via the external power brick. And so it provides the same voltage as the AC wall charger, about 55 volts DC, but it actually has the inbuilt solar and lead acid module in it. So it's basically like an external version. So what that allows me to do is actually I can have both solar, and I can also then connect this up and I can charge off either a standard lead acid battery. I can also draw off a couple of these other portable lithium battery banks that I've got. So if I did need to, I could potentially draw off those units, and I could connect up 2 at a time. So I could actually have one running through the enhanced DC charger module, and then another lead acid or lithium battery charging through the PV connection. And the reason why I may want to do that down the track is that you're very limited when charging from a DC supply. It has a limit of 10 amps, whether you're using the native charge circuit to the BlueYeti or the external enhanced charger. They still have about the same sort of current limitation of about 10 amps at 12 volts. So you're only going to really be putting about 100 to 120 watts into the BlueYeti. So therefore, if I can connect up 2 lead acid batteries, or lead acid and lithium, whatever I'm using, I can actually double that. So I can be putting about 200 to 240 watts into the BlueYeti, which is quite handy. But I have actually just purchased, just ordered over the weekend, the BlueYeti expansion battery, the B230. I've been waiting for the connectors, cables to be supplied, and they've actually started to now supply them, and in fact BlueYeti are supplying it free with the unit. So even though the EB200p is not natively expandable like the AC Max is, I can use this connector, and I can either drive it into the DC charger, the enhanced DC charger, which will allow me to connect up to the AC over on the BlueYeti port, or for faster charging, I can actually connect it up to the PV connection. If I use the enhanced DC charger, it has a maximum output of 500 watts, so that will limit the ability to charge off an external battery up to 500 watts, which is usually pretty good, considering my overall usage load is relatively low. But if I did for any reason need to charge the BlueYeti a bit quicker from the B230, I could connect it up to the PV connection, which would allow me to charge it at the full 900 watts. So I'm going to have some options there, and once I get that unit, I'll do another configuration video on how I'm actually going to connect all that up. As I said, it's not as seamless as the AC Max because the expansion ports aren't on this unit, but as I said, you can still connect it. So I've got a bit of a plan in mind how I can sort of get the best of both worlds without having to reconfigure things every time I want to. So a question, I guess, why do I have that switch downstairs for series and parallel operation? So a couple of little things I've noticed with the EB200p. It seems to prefer a higher voltage. So when I'm actually in series mode and series configuration, and I'm getting a slightly higher voltage here, so we're not drawing any current at the moment, so we're sitting at 132 volts. This is the 4 panels in series. That obviously halves when we go to parallel operation. And what I found is that obviously I've got up to 1,000 watts of solar panel here, but when I'm running 2 and 2 in parallel, I seem to reach the 15 amp current limitation of the Bluetti at about 750 watts. So it won't drive any harder than that because of the current limitation. And actually with external meters, I found that current limit to be about 14.5 volts, not so much the 15. I've also observed, I don't understand why it does this, and BlueYeti haven't really given me an answer. In the parallel configuration, sometimes the BlueYeti will limit its current intake at 9.6 amps. So I've noticed this at all different levels of state of charge or depth of discharge, so it doesn't appear to be related to the actual charge level of the BlueYeti, but sometimes it will actually current limit at 9.6, even though the solar panels are able to provide much more. And I know this because if you momentarily isolate the solar, so let it drop off, and then put it back on, the BlueYeti will suddenly come back up to maximum. And it will come up to, you know, whatever the current available is. It might be 12 amps, 13 amps, 14 amps. So sometimes in the parallel configuration, the BlueYeti is current limiting at 9.6, and I don't quite understand why that is. So when I go over to series operation, I'm obviously got all 4 panels in series, and so we're looking at about 8 to 9 amps as the max, because when they're all in series, current is fixed, voltage adds, and also because we've got the low current, higher voltage, we're actually not cutting off, we're not reaching a cutout. So that means that we're actually using the maximum amount as we possibly can from the panels. And I've seen it get up to around the 850 to even 900 watts during optimal conditions. So it does mean we can charge things pretty quickly when we're getting it like that. But the beauty of having a parallel arrangement is that if the panels are in different degrees of sunshine, which depending on where they are, in the mornings that's possible, the panels can operate independently. So if one panel is getting a little bit of shade and the other is not, by flicking over to parallel, I can separate those 2 units, and the current is no longer fixed, and so one panel, one series of panels can actually run a little bit harder, and I can get more power off them until the sun shifts and moves over and actually gets into full power on both sets, and then I can flick over into the series production. So that's why I've hooked up that switch, so that I can flick back and forth. Now this little battery monitor here was the only one I was able to find that could actually handle the higher voltages. This one's actually rated to 200 volts, and it has a 200 amp shunt. Now obviously I'm never going to use, I'm never going to have 200 amps going into this thing, but it definitely was a bonus to find one that could handle the 200 volts of DC. And because when I'm in series operation, you saw before, out in load, my open circuit voltage can be up around the 135 to 140 volts. Even now, we are pulling a little bit of load. It's a little bit later in the afternoon. The sun's moving away, and you can see now I'm only getting a maximum of around 280. So there are some other inline current meters that you can use, and you may have seen them around. I'll see if I can find one that I've got here. They're an inline meter, quite popular with 12 volt systems. Now these are quite cheap to purchase. You can get these, pretty much anywhere. You can get them with or without the Anderson connectors. I've put the Anderson connectors on because I was using this with my lead acid battery. You could easily put MC4 connectors on there, but this is only rated to 60 volts, and all the devices of this type I found would only do up to 60 volts. Now, so if you're only using a smaller voltage solar panel array, then something like that would be very, very easy for you to utilize. But because even in parallel I'm above 60 volts, open circuit voltage is around 65, so yeah, that would definitely not work for me. I did purchase another small battery monitor or DC supply monitor. It's not necessarily a battery monitor, but it was only good to 100 volts. So I couldn't use it when the system was in series mode. And definitely the series configuration is the way to pump the maximum amount of voltage and sort of power into the BlueYeti. It likes the current a little bit lower, like I said, lower than 9 amps, so it doesn't get stuck for that particular reason I'm not sure of, like it does in parallel, and the voltage is higher. So we're actually sort of not limiting anything at all with current or voltage. We're well inside BlueYeti's range, and we can get the maximum amount of power coming off those panels that's available to us. So a question might be around the switching system that I set up downstairs. Now I've got a bit of a crude diagram here that I might be able to take you through. I know it's a little bit confusing here, but this basically is the overall wiring diagram. Okay, so I've drawn this out in different colors to help me visualize. So the blue is when it's in a parallel arrangement, and the green is when it's in a series arrangement. So in doing so, I realized that the two outer connectors never really need to change. It's really only this intersection here that I'm actually reconfiguring when I go to series. So essentially I'm sort of bridging these two panels here, or I'm passing through to a common point. So if we take out that middle section and simplify the circuit, we can start to see here now we've actually got 3 switches that are actually required to take place. So in parallel, we're wanting positive and negative to essentially pass through, and then when we're in series, we want those pass-throughs to open, and we want another switch here to close. So you could do this with a couple of lighting switches, 2-way lighting switches. You would need to use 2 of them. One could accommodate 2 of the switches required, and the second one would need to do the third. But that is a bit risky, because if someone were to operate one switch, not the other, you could wind up with a short here and a short here, which of course would then lead us to a bit of a problem. So there is a switching mechanism you can buy. It's a double pole, so it's got positive and negative, so it's 2 separate poles which are switchable, and then double throw. So it has 2 inputs and it has 4 outputs. So 2 are common, so you have 2 outputs on the positive side and you have 2 outputs on the negative side. And by putting in a shorting loop between the bottom position positive and the bottom position negative, I'm now able to effectively, with one switch between pass-through, positive and negative, or shorted, positive and negative. Now I am in parallel using a slightly higher current. It's only rated to 250 volts and 10 amps. That's a wattage rating of 2.5 kilowatts. Now I'm not using anywhere near that. I mean, the maximum from my solar panels is only 1,000 watts, and typically, we're only getting maximum of 750s to 800s. So I'm not overloading the switch in terms of overall power. And it just means that now throughout the day I can maximize the panels. I can be in parallel operation in the mornings, and then the peak of the day when both panels are in the same lighting conditions, I can flick it over into series quite easily, and of course maximize the voltage that's coming into the system, and of course keeping the current at a more manageable level. So anyway, look, that's the BlueYeti ecosystem I've currently got happening here, and I'll make another video when I get the expansion battery and sort of show you how all that fits together. Thanks for listening.